In this lesson, we're going to talk about a ZBrush plugin that allows us to create text objects as well as generate geometry from scalable vector graphic format files. Now, this plugin is found under the Z plugin menu, and it's called Text 3D and Vector Shapes right here. We'll tear this off on the side of the screen and dock it on the left-hand side. Here I've got the image of the COVID demoni loaded up into the Spotlight. Spotlight is a tool that we use for both texturing and photo reference in ZBrush, as well as for creating geometry. There's a few videos in this series where we talk about the different functions that you can do with Spotlight. So I just wanted to use it here to open this image up and show you how I utilized this particular plugin. If we zoom in, there's these lung sockets here in this creature. Now, the spikes in here I created using the Text 3D and Vector Shapes by importing an SVG file. That is a scalable vector graphic file format, which we'll talk more about in a moment. I used that to generate geometry. And for the text aspect, I generated a text object for the Roman numeral 19, which I then Booleaned out of the head here. So let's take a look now at how we can do this by following along with what I did for this particular project. I'm going to press Shift-Z to exit out of the Spotlight, and here you can see the Z tool itself. Now, I actually have a live Boolean on right now. If I turn off live Boolean and then go into our subtools and open up the body, here you can see I've actually got the Roman numeral that I used to create the negative space on the head. So if I were to select the head, turn the visibility on this, and then turn on live Boolean, you can see that it is subtracting that Roman numeral from the head. Now, live Boolean is another topic that we will go into in much greater depth in a dedicated lesson specifically for Booleans, but we will touch on it in this chapter. I want to show you how I created this object. If we go to this Z tool here, you can see this is the actual Roman numeral text object. If we go into frame mode, it is actual polygeometry. It's extruded with polygrouping for each front and back face as well as the thickness. So let's take a look now at how we actually create something like this. I'll go back to the Polymesh star just to simplify things so we don't have a whole bunch of subtools to look at. To create a text object, you go to the Text 3D and Vector Shapes menu and click New Text. And this just gives you a text box in which you can type text. So here I will go ahead and type the Roman numeral 19, XIX in all caps, and press Enter. And it immediately creates a new subtool. I don't have to accept anything or click anything else. I just hit Enter on the text and it creates a new subtool for me with default settings. Now, here you can see I can edit my text. If I click the Edit button, I can then change what I typed there. If I wanted to change this to XIXV, I can change that. If I go back to Edit Text again, I can change it back to XIX. Now we can select our font. Just by clicking on this button, it'll load up all the fonts that are currently available in the system. So we scroll down the list, we should have good old Trajan Pro here. If I select that, that is the font that I chose for this particular object. Now I can select any font and it will update in here. I'll turn off frame mode so we can actually see the fonts as they update. We can go to System Font. We could scroll up to, let's just grab another font at random. We'll grab Noteworthy. That's dangerously close to Comic Sans. Let's go down here and grab Symbol. And that's going to be not readable. That's not a font that's actually readable. That's, I think, a Wingding font, so we're not seeing that one. But if we go to, let's scroll down further here. There we go, Tecaton Pro. Now, if we have variations associated with the font, we can actually utilize those here. There's bold condensed, we have bold italic. If we go back to Trajan Pro, we have bold and regular. So currently it's set to bold. If I change to regular, you can see the difference between the two. So with this button, I can load a font file directly from disk if I have one that's not loaded into the system fonts, which I want to use. Now, skipping over SVG, because we'll talk about this in a moment, we have the extrusion options here. So if we rotate a little bit so we can see the side, we can change the depth of our extrusion. Now we can also adjust our resolution. If I were to turn this up, we get a higher resolution. We'll turn on frame mode so you can see this more clearly. I'll just press Shift F, and then I'll adjust resolution. And as I turn that up, you see we get more resolution. If I turn this down considerably, it becomes much chunkier. Now there's spacing. Now spacing should technically be called kerning. I'm going to turn off visibility on that polymesh star so we don't have to see that anymore. Kerning is the spacing between letters in typography. So spacing is actually referring to the kerning. So we can adjust that. And then we have adaptive and regular resolution for the font outline. So if we turn off adaptive, you see it's a regular resolution, and adaptive gives us resolution in the areas with the most curvature. Now, this is something that you would utilize if you were getting faceting or some strange artifacting on your geometry. This is when you would want to adjust that. It's on by default. Now, bevel will add a bevel along the edges. So that's a bit too much. Starts to take on a comic quality. So we can dial this back and just give a little bit of a bevel. Now, I like to give a bit of a bevel to something that I plan to Boolean with because it tends to give it just that little bit of an extra facet in the negative space. I think that it can be really helpful, but that will depend on the typeface as to the result that you end up getting. So if I turn this down and then set this to 2, we just get that nice little bit of an edge there. Now the bevel resolution will change the resolution along the bevel edge. Now this is all geometry. There's no clicking OK. There's no committing to this like you have to do to perhaps a mesh extraction. We're just directly editing the settings for this mesh as it appears on screen. Now we have the ability to replace the current subtool with a 3D text with a selected font. So if you were to switch to the star, and let's change to Times, and then click Replace, it will replace that with Times. Auto update is turned on, so when I click Replace, it doesn't actually do anything. So if I change to, let's go to Ping Fang, nothing happens. But if I click Replace, it will now replace that text. So the auto replace is on by default, but if it's turned off, you can manually replace. We'll go back to our other text here. Now here I can change it to be vertical. I can also reverse it. So let's turn off vertical and we can reverse it. Now reversing is not going to be very apparent in this case because it's a palindrome. But if I changed my text, if I edited my text to text object, which is a very creative name, and we'll press F for focus, and then if I turned on reverse, it would reverse that. Turn reverse off, it comes back to the normal text object with the text in the correct order. Now we can turn on, or we can turn off automatic scaling. Turn that on. So let's go ahead and put our text back to XIX. And let's change our font back. Now we have auto update turned on, so this is going to automatically update to Trajan Pro. And I like having it set to automatic update because I don't always remember what each typeface looks like. So it's nice to go through and select them and see which ones I particularly like. So I'm going to add no, that's a good depth there. I don't want it to be too thin, but that seems like a reasonable depth for that object. So now I can utilize this any way that I want in my Z tool. I could apply this as a subtool, or I could use it as a Boolean object. And let's take a look at how we can do that by going back to CovidDemoni. So let's go ahead and zero in on the head here. Now you can see on the creature's head, we've got the Boolean object here. If I turn off live Boolean, you can see there is the XIX object right there. If we select that and solo it, you'll notice that it's actually got some curvature to it. Well, this is using a brush called Matchmaker. And we talk a little bit about Matchmaker also in the chapter on Shadowbox. It's really great for taking one object and conforming it to the curvature of another. I use it often to create tracery on armor or designs on shields and things like that. But there's really no limit to what you can do with it if you think about it once you understand the tool itself. So we're going to take the unaltered Roman numeral and drag it up into this group. And I'm going to make sure that that is selected. and turn off visibility on this one here. We'll turn off solo. And just for the ease of working, I'm going to turn off visibility on everything else. That's going to make life a bit easier for us. There we go. Now, by the way, when you're clicking in the groups here or in the subtools, you may often find that you end up with this little start here when you click on the item. That's a start group, and they're not used as often. Really, I don't use them at all anymore. They were how we organized Booleans before we used folders. A start group is basically the start of a Boolean set. In this case, if I have a start group here, it says there's two objects in it. That's the two things beneath it. This and this are in this start group. So that means that these two things will influence this if we have Boolean set. But we'll turn that off. If you see that, you can just click on it and it goes away. And we're going to use the Boolean options for the folder to actually Boolean this shape. All right, so now what we need to do is move this Roman numeral into position. So I'm going to press the F key for focus, and I'm going to bring up the move gizmo, bring it up to the head. Now this character is posed, so it's actually offset in space a little bit. So I'm just going to hold down the Shift key and do some snap rotation here. And what I want to do is I want to, as close as possible, match the angle of the forehead here with this Roman numeral. I'm going to scale this down, zoom in here, and I'm just going to position this pretty much looking straight down my view at the head, like this. I'm going to move this pretty close to the surface, but I'm not going to countersink it into the surface yet. If I were to try to countersink this into the surface to Boolean, it wouldn't work. You see, it would be inconsistent depth. What I need is to conform the curvature of this geometry to the underlying mesh. And that's where Matchmaker comes in. So I'm going to orient, so we're looking straight down the normal. And I'm going to go to B for brush, M for match, and there is a brush here called Matchmaker. Right there, Matchmaker, it's the M hotkey. Matchmaker has the drag rectangle stroke, and it's a very, very simple brush. You simply click on the object that you want to conform, and then drag, and it will conform itself to whatever lies beneath it. As you see, it's grabbed that curvature. So it's getting a little bit faceted. So let's go ahead and give it some division so it has something to work with. So I'll go to Geometry, and I don't want to divide it like this because it's just going to mess everything up. What I will do is, there's two things I can do. I can turn off the SMT modifier, add a couple subdivision levels like this. Now what that does is it divides the mesh without smoothing it. Then I can divide with the SMT modifier turned on. Now you'll notice that may still give me some faceting in there, some problem areas. So if that's a problem, we could also remesh it. Now you could remesh it using Dynamesh, which would get rid of all those triangles and give us a consistent, evenly spaced quad topology, or we could also use ZRemesher. But let's give this a go with the Matchmaker brush to start with. So I'm going to click and drag, and that gives us a much better result now. I drag and I let go off the model onto the background. So now if I take my move brush and then countersink this, you see that it actually conforms quite a bit better to the surface. A little bit off there, and that's just as a result of my rotation. There we go. So now that will actually countersink much more accurately into that surface. Now let's Boolean this. How do we do that? We go to the Subtool menu and just turn on Subtract. So that's going to subtract from whatever is above it, which is the body. Now I will turn on Live Boolean, and you see it should subtract, but it is not actually subtracting. So whenever you're working with a bunch of subtools and you're trying to do Booleans, it's very easy to get a little bit turned around in your stack. So it's really nice to have folders to keep things organized. So in this case where I am not seeing the Boolean happening, but if we turn on frame mode, we see the Boolean object is actually there. So we know that it should be subtracting. It's important just to go back and take a look at what's happening in your tools. And if you look over here on the right-hand side in my subtool menu, visibility needs to be turned on the XIX. Now we've got our negative space cut out. And this doesn't actually exist in geometry. This is a Boolean at this stage. This hasn't been turned into actual geometry. Unlike this piece here, if I select this UMesh Covid-Damoni and solo it, you'll see this actually has a Boolean applied to it. This is actual geometry. And the way that I created this is, we'll drag this down to the bottom of the stack so it's out of our way. And we'll go to the original head here and turn off solo. Turn off frame mode. On my group, on my folder, there is a gear. And if I click that folder, there is an option for Boolean folder. So if I click Boolean folder, it will apply the Boolean, which is in this case simply the subtract from the body. So it's creating a union mesh right now. And in just a moment, it will update by hiding this folder and appending a new subtool underneath it, which represents the Covid-Damoni's body with the Roman numeral subtracted from the forehead. So let that finish. Just a little bit more thinking to do, and there we go. There you can see we have our UMesh Covid-Damoni, and that has been applied to the surface. That is actual geometry. It is no longer a live Boolean. If I turn a live Boolean off, nothing disappears. I could come in here and I could do some smoothing on this with the smooth brush. I could take the damn standard brush. Maybe I want to create some sort of little slashes around it so it feels like maybe it's been cut into the skin. I can do that. Now, I mentioned that there were other ways that we could retopologize or change the format of this Boolean object other than just doing a subdivision on it. So I'm going to undo back before our subdivision levels just with Control Z. Go back into frame mode. Now, it's pretty simple to Dynamesh this. We could Dynamesh it, and that's not going to give us a good result. So let's turn our Dynamesh resolution up. Now, our scale is quite large on this object, and that is going to impact our Dynamesh resolution. That's another reason why it's important, if not at the start of your process, at some point in your process, to unify your scale, because it will make everything behave more consistently in ZBrush. If you haven't watched the chapter yet on Scale Master, I recommend that you check that out, because ZBrush scale is even more important now in terms of the cloth dynamics, because it's very important that all of your meshes be within the ideal ZBrush scale to work best. So I'm just going to turn up my my resolution again here on Dynamesh and Dynamesh. And there we go. So that is one method that we can get, but it's not ideal. You see we get a little bit of jaggies there. Another thing that I could do is go into my Gizmo deformers, and we have Remesh by Union, Remesh by Dynamesh, Remesh by ZRemesher. I can take Remesh by ZRemesher, and this is a deformer version of ZRemesher, and I can set my target polygon count. I can just turn that up, and then that will remesh this geometry, and it should cut better edge loops for us around the surface. We go into frame mode. There you go. That gives us a more unified and workable tool. It's not an ideal topology, but it's much better than the triangulated mesh we had before. It alleviates all that faceting that we were getting as a result of the triangulation. If we go back to our subtools, let's turn off Solo and turn visibility back on the creature's head. And let's turn off the Boolean at this stage. Now I'm just going to reposition this, because in our undos, we actually undid some of that repositioning. So I'll go back to my gizmo by pressing W twice. Just snapping as close to a side view of this. This is easier to do, by the way, if you are actually at origin, but this character is posed, so it's a little bit trickier to get it lined up just right, but it's not at all impossible. So let's zoom this out a little bit. I'm going to hit the gear icon, and I'm going to accept that remesh so that handle doesn't keep coming up. There we go. Now I will go to my brushes again, go to B for brush, M for matchmaker, and the M hotkey. Drag rectangle stroke, click and drag, and there we get that nice curvature. We can now perfectly countersink that into the surface. And you can do a little bit of tweaking here and there. It shouldn't take too much to get that to line up just right. Now, if we set this to a Boolean subtract and turn live Boolean on, we should get our proper Boolean. We have something interfering with it, and that's the head, that's the mesh under here. I just need to turn visibility off on that. There we go. So there is our subtraction. Now, in addition to the text object, you remember I said that I used the vector shapes to create other parts of this character. If we zoom out, take a look at the chest here, the lungs feature these very, very wicked lung sockets, these very nasty looking little biomechanical pieces that are socketed into this creature's lungs. Now, these mechanical elements I created using an SVG file, Scalable Vector Graphic Format. So let's take a look at one of these sockets on its own without the rest of the model. So here you can see one of the lung sockets as just the separate subtool stripped out from the collection that makes up the Kofidaemoni. So there's a variety of subtools here that make up this piece. I have the lung socket legs. If we solo this, you can see that's just an individual bit of geometry there. I have the crisscross sort of hook pattern that was made from that. I have another piece that makes the interior hooks, and then I've got the socket itself, which is a combination of these sort of dental features and some flesh. So I used an SVG file to generate these shapes here. Now, what is an SVG? An SVG is a vector graphics file. That means instead of being pixels, instead of being a raster image, it's an image that's made up of curves and paths. That means that it's scalable. It's not subject to any resolution limitations. It's used very often in advertising, and it's used in graphic design. And what it allows you to do is take an image that you perhaps created in Illustrator. Adobe Illustrator makes SVG files, and then bring that into ZBrush and generate geometry from it. So I have actually done that, and I have made the SVG file available for you in the downloads. Now, Photoshop does export SVG file formats, but it's not actually reliable. If you do have access to Adobe Illustrator, it would be a better choice if you want to create your own SVG files. That said, it's very easy to find SVG files online. A lot of Wikimedia Commons images, those will be SVG file formats like logos and whatnot. You'll find most logos and most branding available online as an SVG. You can do a Google image search looking for SVG file formats, and you will find them. So I'm going to go to my folder here where I have stored this particular graphic image, and I want to show you what it looks like. So let me bring up my browser window on another screen, and I will pull this over. Now here we can see the SVG file that I have made available for you for download, and this is the exact same one that I used to create the geometry. This is a curved path that's been filled with a color, and I made this in Adobe Illustrator. I was just trying to make something that looked jagged and wicked and had some nice scalloping to it to repeat that shape and make an interesting sort of lung hook socket for this particular creature. So if you're not familiar with how to make SVG files, they're not very difficult to do. It's literally just placing points in space and adjusting curves. If you can polygon model, you can definitely create one of these. And they're very, very powerful. It's a very powerful tool to have at your disposal. So this SVG file is saved on disk, and we are going to go back into ZBrush now. And just like we did with text, I'm going to load this up using the Text 3D and Vector Shapes plugin. So once again, I'll move over to a Polymesh star. That'll just make it a bit easier for us to see what's happening. We don't have a bunch of subtools to contend with. I will go over here to Text 3D and Vector Shapes, and I will click New SVG, and that will bring up a browser where I can browse to that particular file. So I'm going to go up a level here, and bring this over. There you are. So you see we've got our SVG file here. If I load that up, immediately it drops right into ZBrush as a subtool. So I can turn off visibility on that polymesh star, and we can zoom in and take a look. So right off the bat, we can see it's not real high resolution. It doesn't capture the curvature quite as well as we want it to, and it's potentially too thick. So just like we did with our text, we can adjust the extrusion settings here. We can change our resolution settings here. We can turn off adaptive and just give it an overall resolution, or we can turn on adaptive and give it a resolution like that. Go into frame mode, you can see what that gives us. I'll turn my bevel down. If we turn adaptive off, turn adaptive on, well, this is mostly curvature, so we might not actually see much with adaptive. So we'll do that, and then let's turn our extrusion down a little bit. That feels more like a blade. And this is a great way to create blades in ZBrush when you're doing booleans or making weapons and whatnot. I could add a bevel on here if I wanted to have a bevel along the edge. Maybe I don't want that bevel to be quite so thick. I'll set that to 12. And there we go. Turn off frame mode with Shift F. And if I'm happy with that, there's nothing else to do. I have created this bit of geometry. So let's go ahead and open up the gizmo. Maybe rotate it a little bit like this. And I'm going to unlock my gizmo and then reset it and lock it again. So I will go into the gear here, just like we did for the text, and we'll remesh by ZRemesher. So it's currently 640 polygon faces. So this remembers your previous settings. So we can set it up to 4,000 faces. I'm not terribly worried about a good topology right now. I just want to get a nice shape. I want to maintain that nice shape and get rid of some of that faceting. And that's quite good. That works out. I could even turn up my resolution on that if I wanted to. And that would clean things up even a little bit more. Now, something interesting that you can do, I'm going to go to the gear and I'm going to accept those changes so that that handle doesn't keep popping up every time I hit the Alt key on my gizmo. We have another chapter that's specifically on array mesh, but I just want to show you this because it works neat with this particular tool. I'm going to change to a metallic material just because it makes it more fun to look at. And I'm going to go to the tool menu and I'm going to go open up array mesh, turn that on. Now, array mesh is a way of instancing geometry in ZBrush. It's pretty cool what you can do with it. So if we look at our guide head here, we can see that we're looking down on the y-axis. So what I want to do is I want to rotate this character, or excuse me, rotate this object, I should say, around the y-axis, let's say 360 degrees. Then I'm going to increase my repeats on it, and that creates a shape like that. Already quite cool. Now I will go to offset. Now, if we look at it from this direction, looking down the z-axis, I want to offset it in X. And if I offset it in X, you see how that actually changes the geometry that's created. Or if I go to my pivot and then change the pivot in the z-axis, we get something like this. You see that we can make all sorts of really cool shapes by repeating this in instances. Maybe I want to rotate this around the x-axis. I go to rotate, and if I rotate it around the x-axis, I can get something like this. If I want that rotation to be completely the same all the way through, I'll just flatten that curve, and I can rotate it like this. We'll set that back to 0. Close that curve by clicking close here. Let's try another rotation. We're rotating around Y. Let's do rotation around X. There we go. That's pretty neat. So something like that, you could create a crown, you could create architectural elements. There's no limit to some of the things that you can come up with based on this particular tool. And if you like your array mesh, you can just click save, and you can save that array mesh out and as a preset, so you can load it up later. So I'll save this to disk so you have it available to download. So we'll call this crown array. and that will be in the downloads for this chapter. So that is 3D text in vector shapes. It's an amazing tool, and I didn't realize how useful it would be until I started using it, and I find all sorts of applications for it. It inspired me to revisit Adobe Illustrator, which I really hadn't used for many years, and now that I've got a really consistent everyday application for SVG files, it's great to have in the arsenal. So I highly recommend that you check this out and see how you can use it in your own workflow. So I hope you've enjoyed this video, and I will see you in the next.